sure to ask them when we either take a break or when we get to the end, so we make sure we get everybody's questions answered. Sound good? Let's go. Come on, there we go. Some of the key Lennox products that are going to come out this year, A2L. We're going to focus mainly on our single stage units, which are, sorry, I can't see behind this screen. I want there we go, the laser pointer. I got a couple screens going. I can't see sometimes. So looking on this page, anything with a V in it is variable. So there's their ELKPV, which is their new heat pump. Anything with a K in it has is an A2L refrigerant. For them, for Lennox, it's 454B. This is their variable AC, single stage unit, and then single stage heat pump. Nothing too crazy. They all look the same because I'm pretty sure they're the same picture Lennox posts online. And then I will reference back to a couple of furnaces in the Lennox product line while we're talking about the Lennox stuff, namely these two models specifically because they've all been converted now to they've got an A2L equipped PCB control board. So it will take a sensor, an A2L sensor, and it will be able to test. You'll be able to test, and we'll get into that stuff too. I won't focus too much time on these furnaces specifically. They are GWP enabled or low GWP enabled. They have been for quite some time now. I think Lennox brought them out last year, mid season, something like August or something. We were starting to hear talk of having to actually turn off some of the A2L capabilities because of the units we were installing still were not A2L equipped. So we had to turn off some of the functionality. Let's get into it. Before I get started, actually, one quick question. Is there anything that you guys want to hear about or have heard or are questioning, stuff you want to maybe better understand that maybe you have concerns about? Something that maybe, I mean, from an installation perspective or technical perspective, I can answer for you or get, open a discussion up. By all means, mic up if you have questions, or even type them in the chat, or a specific area of concern you want covered from like I said, from a technical perspective. Yeah, please let us know. Moving along. So, for those of you who have yet to see an A2L enabled air conditioner or heat pump, this is now the first 3 pages of the manual. Not a single instruction in sight. Nothing but warnings and cautions and importance and pay attention here. It's kind of what we're kind of looking at. They direct your attention immediately to all these cautions and warnings. They identify things that you need your undivided attention, things like that the refrigerant is mildly flammable, which we're already aware of. Maybe some more stringent safety practices are going to be required when installing, like making sure we're planning to work in well-ventilated areas, preventing any possible sources of ignition while incorporating other safe installation practices, like routing your piping, proper supports, materials. And of course, I mean, you guys are probably already doing this, but making sure we're flowing nitrogen before, after, and during brazing. Of course, having a fire extinguisher within reach. You guys know this, coming and doing a lot of retrofit, but lockout, tag out, test out, making sure that is electrically isolated and safe, and you're gonna walk away from that job safely, especially when it comes to electricity. Things like safe refrigerant management and handling, storage. There is some really good reading in these manuals. So again, specifically the Lennox seem to be a little more well-rounded, a little more comprehensive. So I mean, if you're gonna get online and start reading some manuals, these are definitely good ones. The Carrier manuals and the Goodman, Amana, Dakin manuals, they were reasonable. But they just didn't seem to be quite as comprehensive as the Lennox stuff. So I would strongly encourage you to take a minute and just go through these warnings and cautions and better understand what it is the manufacturer is trying to spell out, so that you know that you're working safely before you jump into any A2L based installation. One thing that's new for all of us. So installation planning, speaking of installation planning, the indoor space where this A2L, AC, or heat pump is going to be installed now requires a kind of a little more careful consideration. Based on the total refrigerant charge, as you can see across that highlighted table, that TA min table, is a minimum condition space requirement. Now, it doesn't look too crazy. That warning in the left corner kind of explains it. This is page 4, by the way. So the warnings do continue. Anyway, basically what I'm trying to say is there's now a total area minimum based on your system, total system charge. That includes piping, any additional refrigerant charge for piping. If you've got a larger indoor coil for, say, a heat pump you're pairing up, you want better heating output or it's a match system for HRI compatibility, or you're going to get a rebate, or your homeowner's going to get a rebate. You may need an additional charge that might push it over the 10 or 15 pounds. The warning on the top left also states that there cannot be an open flame appliance without an effective flame arrest system. Any gas appliances like furnaces and gas-fired water heaters within that same space will both need to be considered. And we're going to get into a little more detail as we kind of move forward, but I want to go through an example, sizing the room first, kind of give you guys a sense. So you guys actually can open up your mics here because you're going to see what's coming. I use the EL18 KCV, so that's the new 454B low GWP equipped air conditioner, single stage AC, which is their Elite Series variable model. You can see the refrigerant weights as the units have been produced and shipped in specs on the chart kind of below here. So where that arrow is kind of pointing to, even up to the 5-ton model all the way at the far right, they all ship with less than 10 pounds and will allow for up to the standard 15 feet of line set that Lennox traditionally does. Carrier's the same way, Goodman is the same way, 15 feet of line set before you've got to add any additional charge. Continuing with the 5-ton, let's make an assumption. We're going to put it in a 1,000 square foot building or a home with a gas-fired furnace. So that's what you're seeing kind of in that corner picture there. And you're going to install a new A2L EL18 KCV 5-ton. According to the TA min chart at the very top, which is right up here. You guys, where's my pointer? Right here. Is this home suitable for our new 5-ton A2L system? Do we have enough minimum conditioned area to satisfy that TA minimum table on the very top? Anybody, just open your mic and say yes or no.
Yes.
And what makes you say that?
I'm seeing 149.9 as the minimum conditioned area, and we have that.
Yeah, exactly. It's not overly complicated, very, very simple, but it is different from what we're used to. This TA minimum table, you're going to find it or something like it, depending on the manufacturer, on the indoor coil. There'll be a sticker on it. It's also in the manual, of course. This is where I pulled this from, but there's going to be a sticker on the front. Carrier uses a multiple of every pound of refrigerant, you multiply by 15 for your minimum square footage. If you guys got pens and papers or something to write on, or something to take notes on, just a couple of minor, I guess, important notes for the refrigerant you're going to be using. R454B, which is going to be in your Carrier product, ICP, Bryant, Lennox, probably Airflow. You're going to find that its lower flammability limit, or its percentage, is 11.3%. And its upper flammability limit percentage is 23.6%. And then the Dakin, Amana, Goodman line is going to be R32. Its lower flammability limit is 13.6%. and its upper is 28.4. So they kind of range pretty close. I mean, R454B is made up of about 70% R32. So it's not surprising that their flammability limits are pretty close to each other. And one other quick side note. I mean, not that we need to be concerned about it, but R410A, the refrigerant we've been using for the last, since 2006, I want to say. That was it was pushed onto us. I mean, I think maybe just a little before then, maybe 2005. It was made up of 50% R32. So we've been using a kind of an A2L what is it now considered A2L refrigerant for the last 20 years. So nothing to be genuinely concerned about. We have been using it. Just now that the actual chemical makeup of it makes it mildly flammable. Anyway, the whole point of this table is that yes, there is an area minimum now that in the event that the entire refrigerant charge dumps into that space, it needs to have a minimum conditioned area of about 150 square feet. There's also a note here that you can see this highlighted where it's called Q minimum table. Basically refers to the fact that there's also a minimum CFM required during dilution. When I say that, what I mean by that is in the event there happens to be a refrigerant leak, maybe one of the lines has a small leak, or the coil has a small leak in it, or one of the elbows, one of the manufacturer's joints has a small leak in it, a couple years down the road. There is a sensor in the coil, or on the coil, that will sense a small amount of refrigerant, actually about 1% of the total concentration in the air. At about 1%, Lennox will turn on their dilution or mitigation process. The board will bring on the fan, shut off all the heating sources and cooling sources. But there is a required minimum of 271 CFM for 10 pounds of refrigerant. And you can see on that chart, there are a series of different refrigerant weights and how much refrigerant is required, or how much CFM is required to be moved if there is a leak. Goodman handles this a little differently, especially with their TA minimum chart that we just covered. They instead of using pounds, they use a tonnage. So for instance, if you had a 1.5 ton piece of Goodman equipment, or Dakin or Amana, they would say you require 200 square feet or 180 square feet minimum. Lennox uses, and Carrier uses, per pound, basically per 15 square feet, or 15 square feet minimum per pound. Basically provides enough dilution so that it can't actually ignite in the space that it's in. And then if, God forbid, there's ever a leak, we do have a minimum CFM required in order to dilute the refrigerant throughout the conditioned space so that it doesn't ever become concentrated enough that it will actually ignite. Now to that final warning. So this is this interesting piece I think a lot of folks are having a little bit of trouble with, and we're still getting some of this stuff ironed out actually with Lennox, because we don't like the way a lot of this is written. But because the way it's written, we have to kind of adhere to it, because currently this is the manufacturer certified instructions. So as I mentioned earlier and highlighted within the warning there in green, the mechanical room can no longer have a source of steady flame or spark producing ignition, which includes gas appliances, unless they are equipped with an effective flame arrest device. So in or around 2003, FVIR or flame arrestor safety devices were required on tank type water heaters. So anything previous to 2003 may not be equipped with some sort of FVIR device, which means that most of our water heaters we work with should already be equipped. Note the ream tank example, utilizing a few of these devices, like the arrestor plate in the bottom. So I don't know if you guys can see right here. The entire base of this unit has a plate in it that is actually an arrestor plate. pardon me, and a spring-loaded combustion air shutoff plate, which is in the base as well, where combustion air is provided through. There's also that glass kind of flame arrest system. This thing's in my way. Wish I had a different screen. Right here. So if you look at this thing, that is the TRD, or thermal relief device, that will break if it's overheated, causing that spring-loaded door to kind of close and prevent any air from entering the combustion chamber below. Now, if I could just get this to move forward, everything would be fine. There we go. More often, most water heater manufacturers will utilize a flammable vapor sensor, like the one pictured on the bottom left, combined with an arrestor plate or an arrestor screen that also meets this standard that we're talking about, an effective flame arrest system. Be aware of the other possible gas or spark generating appliances near the A2L refrigeration systems that you're being installed, and maybe advise the homeowner of the same. We've kind of had this conversation amongst us ourselves and trying to get clarity on things like fireplaces, gas dryers, electric dryers, kind of in the same space. Right now, the current understanding is that as long as the room that spark generating appliance is in, if it's the dryer or the electric, maybe a fireplace, as long as we meet that TA minimum room size for the mechanical room, if the door, for whatever reason, the mechanical room happens to be sealed up with one of these spark generating devices, that's enough space to allow for that piece of equipment to be there. That is our current understanding, but we are still learning, and we're still trying to get clarification from Lennox, because their manual is probably the most strict sounding, especially in this warning. What other spark generating devices? I mean, you guys are out in the field. Is there anything you guys are seeing in a room where you're going to be installing this stuff besides a water heater and a furnace, or a dryer or a fireplace? Anything else you guys typically see? Maybe not typically, but on the occasion you might see.
Homeowners that like to have their own little workshops in the area of the furnace.
Oh, yeah, that's possible. Sure. And there's a perfect opportunity to have and hopefully what's happening is the sales guys, they're going to get introduced to this stuff too. And so that they can have a conversation with the homeowner as well. At the same time, you guys are the gas professionals too. So it may need to be reinforced by you to say, yeah, what the salesperson has suggested to you is the right thing to do. Lennox has got another approach, so we'll kind of get into that too. But there is a way to there's a workaround, we'll call it. Gas furnaces and gas water heaters are likely to be found in that same space like we normally would. Thanks, Terry, by the way. It sounded like you. I think it's you.
Yes, it is.
Yeah. Okay. Good morning, Terry.
Good morning.
So Lennox, sorry, go ahead.
I just had a thought. With the sizing of everything, does that mean the EMCs are going to write down what the square footage is that's permitted to say it matches what's required in their notes?
I haven't got a clue, Kirk. I haven't got a clue.
Likely a good protocol, since they're selling the equipment, they can measure it up.
Yeah, 15. Yeah, and a good rule of thumb again is 15 square feet per pound of refrigerant. Oh, but I guess in the same breath, Kirk. I mean that line of questioning, the salesperson would have to know how much refrigerant is in the piece of equipment they're selling in order to size it correctly. You know what I mean?
You just showed us a chart.
No,
amount.
I know.
Well, regardless if they know how much,
it would have to be verified on site for sure.
Oh,
it would have
for
to be
sure.
verified.
I'm just thinking, if they can at least make sure it meets the minimum amount,
yeah.
And as long as it meets the minimum amount, then we can verify once we get there. But
well, you're going to see in a second here too. There is a bit of a workaround too. So I'll show you what I mean in a minute. But it's a good question. So for instance, on screen right now, Lennox has this external RDS board, can be put on after the fact. So for instance, you put a new A2L heat pump or air conditioner on an old legacy system that they're not being, they're not replacing. So there was another furnace there. It was installed 5 years ago. Nothing wrong with it, but it just so happens the homeowner's changing their air conditioner or heat pump. This board and a sensor can be put on and tied in as a pass through, basically the thermostat down through the thermostat wire. This basically sits in the middle of between the thermostat and the furnace. It just acts as a pass through. And all its only job is to, if there's ever a leak, it stops the heating or cooling from functioning. We'll get into it a little deeper, but and then Lennox has a couple versions. They have a 24-volt version and a communicating version. And then for those furnaces that are either already installed or being installed with your system, if perhaps I'm gonna use Lennox as our primary example, as I said earlier, but so Lennox, this is their SLP control board, at least they're an image of it. It has a couple of sensor locations right here and the push button right here for the test. And then the dip switches down here to set it up. These are the furnaces that are like their EL296, like we talked about, or 297V, and their EL290, or sorry, SLP99 UHV is also going to be equipped with these boards. So if you are installing a new system, it should already come equipped with this board. You shouldn't have to worry about having to install an external, and then everything wires up just as it normally did. This external one is the only real bolt on if you're putting in something with a legacy system. And we'll get into these a little more in depth as we kind of go along, but that's basically what you're going to find. Carrier is not going to have, so I don't know what you primarily are installing for when you're putting this stuff in. Carriers is always going to be an external board with basically like an 8-foot whip with labeled connections. So you'll bring your thermostat wire into the new box. So it'll look very similar to what Lennox has here. Their cover is clear or opaque. And then there's going to be an 8-foot kind of snake that you'll tie into the furnace that's already pre-labeled. You just bring the labeled connections into the connections of the furnace control board or air handler control board. As far as I know, Carrier is not planning on upgrading their systems to include an A2L board or an A2L or low GWP equipped PCB into their furnaces. They're just going to stick with their standard furnace model lineup, and that external board will be put on. Goodman, however, is going to go the same way Lennox did. They're going to have an external board for those, AC or heat pump only systems that are being installed with a legacy system, but they're also upgrading their internal PCBs to be equipped with a low GWP PCB. That's a lot of letters together. They're going to use the same strategy as Lennox. There we go. There's a look at one of those sensors. And it's wiring harness, test buttons, sensor locations. Yes. This is one keynote I want to make sure that everybody takes away with them. When these are being installed, the small test button that's highlighted in blue will need to be used specifically on this one. You push it once, and we'll get into it a little deeper to make sure that the units actually shut down the heating or cooling and that they go into that fan speed or fan only so that there's dissipation, and it shows that the control board will tell you it's in dissipation mode. But we'll get into the specifics of that further on. But these need to be verified that they're operational, and that in your final technician install notes or commissioning notes, it has to show and has to say specifically that these systems were tested and proven functional, so that they know that in the event there's ever a leak, that they were tested and proven that they operate if there is ever a leak. Again, a couple of side notes, nothing really crazy. Clearances for the outdoor unit. I mean, they want service clearance on either one of the sides that are adjacent to the control box for the service technicians that are going out to work on these things. Again, I highlight the one on the right side there. You can see that's highlighted now. I would pick that because typically the piping line set comes off the house on this side over here. I would rather have a shorter space up against the house if I'm installing that. So I'd take the 30-inch from the backside. 36-inch on one of the open sides in between the house if you're going to put this unit in, if it's not a side discharge style. You can have as little as 6 inches to the wall for this unit. Specifically, this is the Lennox, that kind of oblong shape. And then, of course, on top, minimum clearance of 4 feet. Nothing too earth-shattering here. Please, for whatever the manufacturer is requesting for service clearances and airflow clearances, please make sure that we're following their suggestions. A2L, best piping practices. So now, we've got the indoor unit kind of sitting on top of the furnace or air handler is installed. And then we've got the outdoor unit plates with the appropriate clearances. The new line set can be installed. R454B refrigerant piping practices in general have not changed much from what you're doing with 410A. Like I said, R32 makes up 70% of R454B, and it made up 50% of R410A. So we'll talk about a couple of the key differences that's coming, at least with Lennox anyway. Lennox uses now a pipe sleeve. You can see these pictured here at the 2 indoor joint connections. They are slid over the brazed joint to prevent any possible leak at either joint to be forced basically into the case portion or the ducted portion of the coil where the refrigerant sensor is located, with the hopes that it'll activate the leak mitigation measures at the refrigerant detection system, which is the control board we just looked at. You can see on the picture, there's a gear clamp at the back end of the sleeve, and that's basically to prevent any refrigerant from basically seal up that sleeve around the back end of the pipe. It does come with some instructions if there is some confusion or concern about how they should be installed. That, like I said, that gear clamp will basically keep things sealed up, force that. If, again, God forbid there's ever a leak at the joint, it will force it into kind of this section of the coil. You can see how this open space here would push the refrigerant into here to where the sensor is located, and it'll activate those mitigation procedures from the RDS board. But it's not every installation that has one single joint at the sleeves. And as far as I know, Lennox is the only manufacturer that's actually utilizing this sleeve system. None of the other manufacturers are using it. So Goodman's point of view is if you have a joint in your piping or several joints in your piping, they need to be made accessible or left accessible. The oil that's in the systems is going to be the same or very similar to what 410A is being pushed with. So the oils are very similar. Still, all the manufacturers I read suggest flushing the system regardless of R22 or 410A so that your oil has been removed. If you had, for God forbid, had to reuse some of the line set, hopefully you won't have to. Ideally, we would like to have new line set put in.
You mentioned that the joints have to be left accessible. If you cover an Armaflex, do you have to make a cut in the Armaflex where the coupling is and tape it with a marking of some kind?
No, I don't think so. Not that I'm aware of. Nothing is stated in any of the manuals that says leave it marked where there's a joint, just leave it accessible. So if I've got Armaflex as a technician, I mean, I can cut into that myself. But as long as it's accessible, if I needed to get to it, I can get to it. So it's not basically, Kirk, it's a good question, but basically they don't want it covered up with drywall or covered over. I mean, now, to be fair, you can't stop them if the homeowner puts a drywall up after you've been there. But as we are aware, and the way they want it put together is that they want it so that there's no additional, ideally no additional joints inside. But if there are, they need to be left accessible. Now, like I said, Goodman or Lennox has a different strategy. You can actually add a second sensor to one of the control boards. I don't know if you remember seeing the control board pictured, or how there are actually for Lennox, and Lennox or ADP is the other coil manufacturer using that external RDS board. that one that what I showed you with the Lennox that was pictured, they're using the same one. So they both have 2 sensor mounts. So you can actually add an additional sensor outside of the coil. So if your room doesn't qualify for size, if you have additional joints in the line set, there's a couple of different ways or a couple of different qualifying factors within the manual that basically say if you need to add or if you have this extra joint or you don't have enough TA minimum or you have a spark generating device in the room, you can add a second sensor. This is Lennox's approach. All of the other manufacturers outside of Lennox and ADP, they are not using a second sensor. They're relying on a single sensor within the coil to pick up any refrigerant detected to start those mitigation processes. Lennox's list here on the left, I'm not going to go through them, but basically they're saying within 0 to 9 inches of the back of the furnace, on the side of the furnace that doesn't have the return on it, they want you to put a sensor in there, a minimum, basically 9 inches off the floor, but below the refrigerant or below the burner of the furnace, install the second sensor. And the control board, you can tell it's got, 1 or 2 sensors, and we'll get into that, the depths of how to set that up, but you can add a second sensor. Line sets don't change for Lennox too much. Once you get, I pulled this out of the EL15 KC1, which is their single stage AC, and it just goes through each of the individual sizes. But if I was to pull any one of Lennox's pipe sizing charts out, at 3 tons, you can see the suction line changes to 7/8, and then at 5 tons, it changes to 1 inch. Now, Lennox does have additional documentation for anything beyond 50 feet. For their piping and design guidelines, and they offer a couple of suggested piping practices within another document as well. Now, I think this was the same as the 410A because this comes out right out of the 410A design manual. This is the one they're directing you to, is anything where your evaporator is below, or I shouldn't say your evaporator, your line set rises any more than 5 feet out to get outside your outdoor unit. If there's more than a 5-foot rise, they're expecting a trap to be installed, basically to ensure that the oil doesn't log out in the indoor unit or at the evaporator. It gets pushed back or entrained within the refrigerant, gets pushed back to the compressor. And it does so by trapping, basically creating a trap and forcing the oil back with the refrigerant flow. Again, the piping, if you're looking for you're having trouble sleeping, you're looking for something to read at night, the refrigerant piping design guideline is it's great reading material for that. But if you just have some general questions, they have some pretty good answers on how to pipe and how to apply suction traps and riser traps if you need them, and anything beyond 50 feet within the piping guidelines. And then here is a couple of kind of just images out of that piping guideline document showing how they isolate the piping system from the actual structure of the building so that it doesn't cause creaking and cracking, get unusual rubbing or unusual wear and tear on the piping system. Again, this isn't exclusive to Lennox. I've seen this in the Carrier and the Goodman manuals as well, where they actually hang rather than strap to their joist as a suggestion, so that when there's expansion and contraction on the piping system, it can kind of move freely. It's not restricted by being held against or strapped tightly against a joist. And the only reason I bring this up is, I've had a couple instances where we've had to install. Lennox has a kit. Lennox has a kit that I had to install to stop this kind of sympathetic harmonic that was vibrating through a piping system, one specifically in Fort Erie. I installed around kind of an elbow just before it went into the building, because the homeowner was getting this weird just weird vibration / hum in their house. And once put this kit on, it kind of seemed to correct it, but I think the piping was strapped to the joist, like directly to it, and not hanging from it like this. The one thing I actually really like about the way this is drawn up is right here, they even isolate or suggest isolating the line set even in your penetration for the exterior with either a bead of silicone or some sort of sleeve would work. That's when I ran the line set in my house here last year. I put it through a sleeve, like a piece of ABS, so that it didn't communicate directly with the building, and then filled the sleeve with silicone. Actually made for a nicer joint
James?
anyway. Yeah. What's
Can
up?
I interrupt? It's Richard. Richard here. Can
Hi,
I go
Richard.
back to the oil trap? Hi. Can I go
Sure.
back to the oil trap for a moment?
Yeah, of course.
Where would the oil trap be located? Sorry, I'm just wondering.
Like
If you're going above 5 feet, like where would you locate the oil trap?
so if you've got a 5-foot rise in your piping, I would put it at the bottom.
Yeah.
The bottom
At
of
the
your
co- at
5
the
foot.
indoor.
It actually states it on the last page there, Jim. If you go back a page, it'll say
Oh,
at the
okay.
bottom exactly where to put the trap. I think it was the last page.
This one?
Thank you, guys.
No, it says it at the bottom. There it is,
Yeah.
right there.
One trap
So-
must be installed at the bottom of the suction riser.
Okay.
I don't know if you
So
can see that,
basically
Richard,
at
right
your
at the bottom.
coil. So
Yeah,
it's basically. At
basically.
your coil then.
Yeah.
Okay.
I mean, I don't know how many installations you're going to run into where you've got a 5-foot riser. That's I mean, it doesn't sound like much, but traditionally, I don't think you're going to have much more rise than say 3 feet.
Yeah, triplexes and stuff like that. Richard.
It would be, yeah, you'd
you'd be
have to have,
surprised.
yeah.
Like,
Yep. And then again, this may be just specific to Lennox. This is coming out of
Okay.
their documentation. Otherwise, if there is some concern that, now mind you, physics hasn't changed in, 250, 300, 400, 500 million years, whatever you believe our planet length is. Physics hasn't changed. So I wouldn't be surprised if the other manufacturers are suggesting the same thing or have their own piping practices. They're hoping that their equipment is being installed to a certain specification, especially when you come into these larger risers.
Well,
Sorry, go
suction
ahead, Bill.
traps they're not uncommon, right? Suction traps, right? When you start
No.
getting
no.
a riser, right?
No,
So
I
it's just
realize
that it actually states right there exactly where they want it. So
Okay, thank you.
no
Yeah,
problem.
no worries. Moving along. The rest, some of these best practices are probably not going to come much of a surprise. We want to make sure our piping system is clean. We want to make sure our joints are made, with the limited amount of tolerance as possible, so that our joining materials, whether that's copper and Sophos, etc., are used as best we can. Anyway, so when it comes to sound refrigerant piping practices, it's exceptionally important now with A2L refrigerants, regardless of the manufacturer. First, want to make sure we ensure the piping size is correct for the equipment tonnage, which we talked about earlier in the pipe sizing charts. And then we'll make sure we're cutting with the appropriate tool, make sure the cut is nice, neat, tight, and square. Square it up. The piping itself is round and fits tightly and properly into the accepting fitting, the female portion of the fitting. And then, of course, we'll make sure we want to deburr the interior portion of that piping system, so that we're not making that line set any smaller than it has to be. And then if for some reason you're connecting to a 3/4 inch pipe to a 7/8 or 1 1/8 connection, make sure you're using the appropriate reducing or increaser fitting. We're not pinching or crimping piping or fittings to make them fit and then brazing around them. We're using the appropriate fittings to maintain pipe integrity and joint integrity. And then before brazing the joints inside and out, remove any Schrader cores and caps to prevent damage from the heating of the joints with a torch. Now, a nice side note for those of you who are out there in the field is that, and some of you guys may already know this because you're using them or you're testing them, but there have been some tests on some no braze fittings. They're a 2 wrench style, almost like compression style fitting. that collapses around the piping and basically creates a seal. We tested them in our lab too. They held to, without any trouble, as far as I could tell, when we did the test, to 500 psi. So I think there are some final details just kind of being ironed out. So ideally, we'll get to the point where maybe we don't even have to use torches. We're using a double wrench compression style fitting. Some of you guys said maybe have already seen them. I forget they're called like a turn lock or sweat lock or something like that. Loctite fitting or whatever the heck it's called. They're these bright red compression style fittings, and they work. They do have some that, like, some of them are 90s. Some of them go from flare to sweat, so you can use them on the King Home models. They're a nice little system. I tested them on standard A2L. I tested them on the King Home air handler with the with the flare to sweat connection. They were good. They have straight connections. So it's just to hope that we get the right infrastructure in place so that we know we've got enough of them, and you guys are going to they're going to work safely, and hopefully we won't even have to use torches in the near future. But for now, time being, let's make sure that we're using torches and we're cutting these things and applying things safely. So there you go, looking at pulling the cores out, making sure that those are out of there. I know, I've heard stories of at least back in my older days that these things weren't being pulled out. And sometimes what can happen is the little O-rings on these service port cores, they get melted and they don't seal anymore. Now with a flammable refrigerant on the other side of this valve, I want to be as cautious as possible when I'm putting stuff in. Yeah.
I hate to bother you, buddy. Do you think you can go back a slide? Just not go back a couple of slides. Just wanted to highlight one more.
One more? This thing?
Yeah, go back to the line set there.
This one?
Yeah, I just want to highlight and just let everybody know on the call that, whenever you're looking at a Lennox manual, they'll depict two outdoor or two elbows outside before you get into the tie into the outdoor unit. It's very important that we practice putting two elbows outside before we go into the unit. Does anybody know why Lennox recommends installing two 90-degree elbows before entering the unit?
It's for noise attenuation, so you don't get the vibration transversing through the house.
That's it, Terry. That's exactly where we're going with that, right? So again, I hate to bump in and jump in. I just noticed it, and I said, hey, maybe we should bring that up. But yeah, it's for vibration, especially in the winter, in the heating months, right? We might get that phenomenon of pulsations or vibrations, and it's just a means of isolating that vibration. So
it also
just wanted to bring that up.
Thanks,
it also allows for the for settling of the unit without applying for when the ground shifts and that, so it doesn't put any stress on the pipe.
Thanks, guys. Regardless, we're still using braze connections, so for the time being, it's imperative that nitrogen be connected to purge the line set before, flow low pressure nitrogen during, and purge the nitrogen to cool the joints after. Pictures an approved connection method right out of the Lennox installation manual. Displacing oxygen while brazing has always been important, and with the introduction of the new A2L flammable refrigerants, mildly flammable, mind you, it is even more so now. If you haven't already, please make sure you're set up with your brazing gloves, safety goggles, hearing protection, ABC fire extinguisher that's properly charged, within arm's reach while brazing. With A2L refrigerant on the other side of these valves, keeping these seals cool and protected from any possibility of leaking, they must be kept cool. Like, we've got to find a way to keep them cold. So, pictured, you can see quenched, wet cloth on that side of the valve to prevent any of those seals from being, misshapen during brazing. There's also wet rag putty, which has proven to be effective. I know there's a spray out there, almost like a gel, that will also help keep joints cool. Regardless of your method, let's please make sure we're using an appropriate method to keep those joints or the valves themselves cool. And then, of course, allow them to naturally cool so that we don't crack the joint that you've made by like hosing down the joint to cool to rapidly cool it. We don't want to rapidly cool it. We want it to allow it to cool naturally so that it doesn't crack, or we don't have any possibility of just undermining the joint's integrity. Pressure tested. Leak tested system with our EnerCare operations manual minimum of 300 psi of nitrogen. Once all the connections have been completed, the Schrader cores have been reinstalled. That can be found in section 9. We're going to be following the same process as 410A refrigerant because the operating pressures of the new A2L refrigerants is pretty well the same. Notice how this diagram uses the high side gauge and the hose connected to the low side service valve. Often our test pressures exceed the design safe working pressures for the low side gauge, and following this method can prevent any possible damage to that more sensitive low side compound gauge. Well-brazed joints and a proven leak test are even more important with the possibility of A2L refrigerant, with the possibility of an A2L refrigerant leak. From the commercial side, I did some work on a Scotiabank some time ago where we had to, roofing was being done. So we had to move like I forget what its size it was. I feel like it was like a 20-ton or 25-ton condensing unit off a roof. So lift it up with a gantry crane, roll it out of the way so the guys can roof there. But of course, everything has to be repiped, re-evacuated, refrigerant, etc. Anything over 5 tons has to have TSSA involved, so that you have to go through brazing procedures. They need to see your inventory of piping and stuff that you're using. It has to be approved. So we had to have a dedicated gauge set for our pressure testing. So we didn't have our gauge set, our dedicated pressure gauge set didn't have a low side gauge. It had 2 high side gauges, and it had to be shown in, nitrogen only, pressure test only gauges. It could not be used on any other refrigeration system. And once the pressure test was over, we had to switch our gauge hose system, our gauges manifold set over for evacuation. So we had appropriately, so anytime we were communicating with refrigerant, those pressure test gauges couldn't be on. So it's not a bad idea. The high side gauge is better equipped for higher pressures. It's a great opportunity to use the right gauge for your testing and minimize the possibility of any sort of damage or a misreading on a low side gauge that isn't maybe as equipped to take on as high pressures. Once a pressure test has proven to hold and is shown to be leak free, the system will be evacuated from both sides, low and high, as pictured, and the vacuum monitored by an approved quality micron gauge while following EnerCare's operations manual section 9 evacuation procedure. To speed up the evacuation, use your core removal tools and a 3/8 central vacuum hose from your manifold or one of those vacuum trees. They work pretty good. Remember to put the cores back in before charging, though. Vacuum the system down to at or below 500 microns. Then isolate the system from the vacuum pump for 10 minutes while that micron gauge is still reading. If the micron gauge reading does not exceed 1,000 microns, the evacuation is complete. You can proceed with charging and commissioning. However, if after 10 minutes the reading, or up after 10 minutes, if the reading is between 1,000 and 2,000 microns, you're gonna have to do a nitrogen sweep to kind of relieve that system of whatever moisture is kind of still hanging out, and then relieve that pressure from the nitrogen and start your evacuation all over again. And then, of course, if by chance your vacuum test exceeds 2,000 within that 2,000 microns within that 10-minute test, there's likely a leak somewhere in the system, and the pressure test didn't reveal it. So there's maybe go around and see if you can isolate where your leak is coming from. Who knows? It could very well be coming from a hose connection. Some manufacturers do demand a lower level of evacuation. None that I've currently read, at least not with the new stuff. Anything below 500 seems to be the sweet spot for both Lennox, Carrier, and the Goodman product line. But in those instances, please follow the manufacturer's directions if they are more stringent. Oh yeah, there you go. There's a Schrader core removal tool. If you don't have one, they are a handy dandy little tool. Once you've got a proper vacuum and it's been achieved, you're hanging out below that 1,000 microns. Any additional refrigerant charge required can be added to the system to account for any additional piping lengths or greater than 15 feet, and a coil that's maybe requires some additional charge. Notice the left-hand thread charging adapter that is likely to be required for these refrigerant tanks. I've recently heard that the R454B tanks may actually come equipped with them, but I haven't. Nobody's actually proven that the tank actually comes with the adapter. So for any, I think I heard Richard on the call or saw Richard on the call. You may require these left-hand thread adapters to get onto these new tanks, any of the A2L tanks, and it's just a protection device so that we don't cross-contaminate.
They were distributed with the new tools, actually.
Perfect. There you go.
Yep.
So you guys have them then. That's awesome. Perfect. And then, like I said, anything else? A couple of key points. Just like 410A, R454B is a blend, and it has to be, the only reason it's pictured upside down here, it has to be charged as a liquid. It cannot be charged as a vapor. Get fractionation and basically lose the effectiveness of the refrigerant effectiveness. R32, however, is a single component refrigerant. So if you're doing anything with Amanda, Dakin, or Goodman, they use the R32 refrigerant. That can be charged in either state. That's either vapor or liquid. So just, again, quick clarification, R32 can be charged in either vapor or liquid state. R454B, however, must be charged as a liquid. Terry, I see you got your hand up.
Yes, just going back with the evacuation process and that getting under 500 microns is quite easily done with new refrigerant piping. If you're reusing
and new oil in your vacuum pump. Yeah.
But if you're reusing a line set, God forbid, like there was no discussion about the flushing of the lines. So if it's 410A, are we compatible? Or
we did talk about it earlier. I don't know if you missed it. We did mention, yeah, if God forbid you have to use the line set, you're stuck. The homeowner's not going to let it happen. The line set is appropriately sized and you can still use it. Yes, definitely flush it.
Okay. All right.
The oils are not the same. They are very similar, but they're not exactly the same. The manufacturers all still suggest flushing the system, the piping system, if it has to be used, regardless of what refrigerant was there before.
Okay. Thank you.
Yep, no problem. Now, Lennox now wants you to make sure you mark and tag. I mean, we're going to tag via ODP guidelines, but they also want you to permanently mark their tag outside for any additional charge you're putting in so that you have a total charge listed on the outdoor unit, right on the nameplate. So if you could write in something permanent, like an ink, or I don't know, if you're Anthony Kwan, then you might even have a label maker. You can put a label right on it. You can make a nice digital label and print it off. Any questions on the charging of this stuff? Just because it is a little different than what we're used to with this adapter. But I mean, you guys are probably already charging with 410A with liquid, so it's not that much of a change, but just enough that it's it's not what we were using before.
I have a comment, James.
Yeah.
You don't have to be Anthony Kwan to use a label maker. Anybody can do such a thing. And I know you use my label maker too.
I do.
Label makers are awesome.
See, Anthony knows label makers are where it's at. That's awesome. Thanks, Anthony. I didn't even know you were in here. That's great. I'm glad you were able to add to my my label maker joke. That was good.
Well,
Thanks,
now
buddy.
I know how much you're talking about me when I'm not here. Or when you know I'm not here.
Well, I'm bragging about your label making. That's hilarious. So funny.
Would it be easier to put a pre-made label referencing to CODP tag for additional charge?
I guess, I mean, if the centers want to do that, I suppose it's not unreasonable, but I mean, the manufacturer is specifically asking for it to be written on their equipment in permanent marking. So, I mean, I'd be more inclined to follow the manufacturer's directions, but I'm sure it's not unreasonable to do so.
Yeah, no, it's only because that there's no ink or anything that's actually UV qualified to stay. It actually fades over time. In 5 years, it'll be gone.
Gotcha. Sounds like the maintenance guys just need to carry a pen. keep writing on it. It is 9:30. Why don't we take 10 minutes before I get into this low voltage control wiring stuff, and we'll so we have a better idea what's going on. So let's come back at 9:40.
I'm just gonna put up our sign, Jim, while we're on break.
Yeah, okay. And yeah, so Bill's looking. If you haven't signed in with Bill or know that you've been signed in with Bill, please make sure that if your name isn't being listed as first and last name, Bill, in order to make sure that we, can.
Or you're in a group. You might be in a group.
Or you're sitting there. Yeah, you're in a group or something. Then please, by all means, make sure your name gets typed in so that we can mark your attendance. We have to track who's taking these trainings. If you could kindly either type it into the chat for Bill, if you don't know for sure if you were accounted for, and even if you thought you were accounted for, just type your full name in the chat, first and last name.
There's a list of names in the chat right now that people I don't have. So let's grab coffee, and I'll see you at 9:40, whatever.
Beautiful. Thanks, Bill. I've lost my ability to.
Looks like Anthony's got your number now.
That was so funny. I loved that. Anthony Kwan has a great label maker, and I use it. I like it.
Yeah, I've used one on the job before.
Super handy, right?
Oh,
I used to keep for my electrical. I used to keep the sticker book with letters and numbers, like it just you wrapped wires, so that you could mark them. Because a lot of those specifically a lot of those old York rooftops were just black wire with yellow print on them, and the same thing, the yellow imprint would disappear.
Oh, it's like the old Coleman Evcon heat pumps.
Yeah, just awful.
Waterproof coil, all black wires.
All black wires. You wanted to kill them. Like, why are these all black?
But no, it was great for it. You used to get the rolls in the hard plastic case.
Yeah.
Well.
They were great. I had a flip book that I just could
I
stick.
still got some at home, I think, from those days.
This is the way we dealt with things years ago. Till the manufacturers got smart and continued more often to use those, not only a labeled wire, but a multicolored wire. Anyway, I'll see you guys in 10 minutes. Hello, folks. Welcome back. It is
Jim Bob.
9:40.
All back.
Hi, everybody back? It's good. Let's get into the controls because this is where it gets interesting. As for controls and control wiring, Lennox offers a fully communicating system that you might be familiar with. If you've spent any time with Lennox product, come on, here we go. And it will work with the Elite Series variable equipment, whether that's the Elite, or I should say Elite and Signature Series product. A lot of them are communication equipped for communicating equipment, which, I mean, pictured as the S40, but I mean, there's a couple generations of Lennox equipment that works. It's complete 4-wire system, R, C, I-, I+, connections on all of the equipment, indoor and outdoor, if they're fully communicating. But there is also this lovely 24-volt thermostat. Pictured, I mean, I chose the Ecobee 4. It happens to work with all of them, which is actually kind of nice. Lennox is, I don't know if they've just been pressured into it or finally figured out that not everybody's going to buy their communicating equipment. So their communicating equipment needs to be quality in that it works with all of the thermostats available, or most of the thermostats available in the marketplace these days. The good news is with the 24-volt thermostat on some of their variable equipment, it still functions in full variability. It just needs some attention with some not dip switches, but jumpers on the outdoor equipment, on their variable equipment. We can look at some of those too as we go forward. One key point to kind of take away. Actually, before I get into that, for the variable compressor equipment, wiring is familiar for the high voltage being applied. As you can see, it goes direct to the base of the single pole contactor or 2-pole contactor. But ensure the electrical ground connection has been secured at the outdoor unit before charging with A2Ls. And this is not specific to Lennox. This is across the board. In every single one of the manuals I read, this was one of the qualifying notes. Ensure that the unit is grounded and properly bonded to electrical ground before charging starts. So please make sure you're doing that. High voltage conduit entry points to both the equipment and the outdoor disconnect are to be filled with a low expansion foam, silicone, or a mounted putty as per electrical code, ESA. This prevents any warm indoor air from mixing with the cold outdoor air, specifically during the winter season. That'll form basically streams of condensate inside your liquid or watertight, liquid tight. When pairing the communicating equipment with the S40 or any of the communicating thermostats, follow the wiring instructions as per the installation manual utilizing the RAS connector that you can see right there highlighted. Any unused low voltage connectors can create an antenna. So as you can see, the unused wires are kind of together there in the morettes. And then that low voltage, there's one connector or one conductor that goes back to common, low voltage common. So that, God forbid, there's ever any sort of electrical noise on any of those kind of unused wiring, or it will basically it won't disrupt the low voltage DC signal being sent back and forth down the I+ and I- control wires. The next couple slides are not completely exhaustive of all the wiring possibilities. Lennox, with their RDS system, offers this is the external board. They offer a couple of them, as we talked about before, a 24-volt and a communicating. This one is the communicating. We will go through a few of the more what I expected to be common examples. The Lennox RDS manual that comes with this board has much more examples, things to do with zoning and multiple furnaces, etc., and how to wire those things up. If you had what are those things called? The equipment interface module, the EIM from Lennox. God forbid you had a non-communicating piece of equipment with an S40 thermostat, you might have to use an EIM. There are ways to get all that stuff connected. we've got a couple examples here, probably the most common things you guys are going to see. This is the fully communicating external, again, I repeat, external communicating RDS field kit. It is designed to be paired with a legacy furnace. So for instance, you've got again, we talked about this earlier, but you've got a furnace that's 5 years old, still very good. The customer, however, has to upgrade their air conditioner or heat pump, and they install some of this new A2L product. To me, I mean, this looks like the easiest way to go. Something that's communicating outdoors with the communicating equipment inside, add another 4-wire outside, pair up your new A2L system, and then have it run through this RDS board in the most simplified manner possible. With this, as you can see, this one has a single sensor showing on it. As far as I know, all the external boards from Lennox and ADP are going to come with 2 sensor ports. So you'll actually see a second sensor port sitting right here, even though it's not drawn here. You can see the thermostat connections are going to be on the black connection. And then the indoor connections, there'll be the blue connectors on that board. This is pretty straightforward. Are there any thoughts or questions around this stuff? Again, Lennox specific, they have their own communicating version of this board, this RDS board, when pairing a new A2L system with a legacy furnace or air handler. Doug's back. Next example. So same idea, we're going to pair a new A2L piece of equipment. Specifically, this is one of the variable units because it has the RAST connectors. But we're going to pair it with a 24-volt system, a pre-existing 24-volt system. So the indoor unit now is still one of those legacy, we'll call it an EL296 from 5-6 years ago. It's paired up with a 24-volt thermostat. And we're bringing in a new variable heat pump or air conditioner that's A2L equipped. So now this one is the 24-volt version. It's not the communicating version. The boards look very similar. Just the wiring is a little, I don't want to say a little more exhaustive, but it's a little more inclusive, right? We have our standard signals that we would normally have. So as you can see, this is wired as an air conditioner. And in order to get full variable capacity out of this variable unit, Y1 and Y2 outside need to be jumpered. Not much of an ask, pretty simple stuff. Make sure Y1 and Y2 are jumpered outside. And then the control board outside in this communicating piece of equipment will basically monitor suction pressure to make sure that it maintains a very specific suction pressure or back pressure, so that it'll move through its variability based on the pressure transducer that's in the unit. If for some reason this was a heat pump, the outdoor unit would also have an O or a B terminal, and then the indoor portion would also have an O or B connection. Again, Lennox specific, we must make sure that we install their O wire, because the blower motor is making or the control board is making decisions for the blower motor speed and whether it's heat or cooling. On a heat call, a heat pump heat call for Lennox, if it sees a signal at Y and does not see a signal at the O terminal, it will automatically it'll ignore the ramping, the blower ramping, and go immediately to 100% for a heating call. So for instance, if your cooling fan speed is set to ramp, I think a lot of these motors are I think for Lennox, it's the A selection for their ramping profile. It goes from 35 to 70 to 100 over the course of like 7.5 minutes. If it gets a heating call, that will be ignored. It will go immediately to 100%. So it's important that we wire to that O terminal with a heat pump on the control board in the furnace. The other thing here, of course, is defrost. So in defrost, if we're deciding to temper the defrost for our customer, Betty White doesn't like feeling air conditioning in the heating season coming up, because during a defrost call, we would wire the W wire from the outdoor unit up to this control board as pictured. You can see it. I don't know what you're reading this or watching this on, but the W wire is in green, at least the way I've shown it here, so that you can see it. The only one trick is, of course, when we're putting together fossil fuel heat systems and heat pumps, they are not really designed to run simultaneously. So the thermostats are set up to prevent that. But during defrost is kind of the exception. In order to keep our customers happy and the air tempered in the discharge air so that it doesn't feel like air conditioning, it just feels like the fan is running, you can put in this part number, 67M41. And it's just a 2-wire temperature sensor that goes into the discharge airstream and basically controls the fossil fuel coming on and what temperatures it's allowed to ramp up to. I believe somewhere between 70 and 90 degrees is the on and off for this temperature sensor. It basically just provides enough heat in the air that it doesn't feel like it's frigid during the defrost cycle. And that would be that all that little sensor would do is break that W signal between the outdoor unit and this indoor control board. Any thoughts? Any questions?
Just essentially, if you don't have that sensor, then do not hook up that wire.
Probably not a great idea. That's right. Otherwise, you'll end up cooking the compressor in your brand new A2L heat pump because you're taking on too much heat in your refrigerant and bring it back to the compressor to be pumped. She no good. Damage can be done. And then finally, just a standard 24-volt connection, single or 2-wire out to the outdoor unit. So this would be a non-communicating outdoor A2L piece of equipment paired up with an older legacy system that is non-A2L compliant. Same 24-volt system, single stage heat, single stage cool. Probably so. Again, much like the communicating system, this is one of the more simplified wiring setups, but probably very common in what we do day to day. Any questions on any of these wiring examples we've gone over? Because this is kind of where the rubber meets the road. Controls are not only the most important to get set up correctly, but it's also where our customer interacts with their equipment most of the time. So it's important for these to get put in correctly. All right, I'll move on. Now, I don't recall seeing this in any other manual specifically. It doesn't mean it's not there, it just means I don't remember it. Lennox gives you this kind of wiring picture for their wiring harness for the sensor. Basically, I mean, it's showing basically making a drip loop to prevent any possible moisture from coming down on the coil, hitting the sensor, running down the sensor wire, and into the RDS control board. Sensitive PCB doesn't really like water. What's not pictured here is that loop. You can make it just above the coil drain pan, and it will drip into the drain pan if there was ever any sort of condensation build up on that wiring, the sensor wiring there, before it exits either the ductwork or the cased coil. The Lennox product will come with a grommet to run that wire through from the sensor, so that that wiring is protected from whether that be ductwork or case coil. The case coil, if I'm not mistaken, on the left or right side will have a knockout already there for the harness to run out. So you guys don't even have to drill a hole. So it'll be there when you're ready to put the sensor wire through it. when you're wiring these RDS controls up, whether it goes into the furnace or into the air handler. Yeah, just remember the drip loop. That's all. All right, any questions up till now? Because I'm going to get into the kind of the nitty gritty setup for the RDS stuff. Not particularly complicated. It's actually quite simple. It's very, very, very simplified. But before we get into this, because this is kind of new, I want to make sure we've kind of covered off and got you guys any questions you might have on the stuff previous to this. All right, moving on. So now the RDS board itself can be mounted to a flat level surface within the length of the sensor cabling. So for instance, I think carriers is 8 feet. I believe the sensor wiring for both the Lennox stuff is also 8 feet. So just as long as it's within that 8 feet and you can get that drip loop in and the harness connected to the board, and as long as it's on a flat surface, you're okay. I might suggest keeping it off the ductwork, but I think Lennox's stuff said specifically you could connect it. I mean, verify, but I think they said you could actually put it on the ductwork if you had to, or right on the appliance. If that was one of the more suitable positions. Ideally, a flat wall would be fine.
Does it have a protective cover that it comes with?
It does. Yep. Yes, it does.
And I would imagine that you don't want to place it too close to the blower motors if you're going to mount it externally on the cabinet of the unit for EMF interference.
Oh, I suppose so. Yeah, I see what you mean. Possibly. I don't remember reading anything about that specifically, Terry. Doesn't necessarily mean it's a bad idea. But I mean, as for now, I haven't seen anything in the literature that says that. Anyway, good questions. On the RDS control or the equipped furnace air handler control, you will find a small bank of dip switches that tells the control just how many refrigerant detection sensors are connected and need to be monitored. Again, this is specific to Lennox or ADP because the other manufacturers only use a single sensor. The control board, this external one and the furnace control board, comes expecting 2 sensors. So both of the switches are in the off position, or as you can see pictured on the control, they're pushed, if you're looking at it the way it is now, pushed to the left side. If you're only connected to one A2L sensor on the control, switch number 2, which is right here, there's going to be a little arrow coming up. Yeah, switch number 2 must be moved to the on position or pushed over to the right. We'll go into the furnace one in a second. Using the RDS board pictured, push the switch to the right side. On the furnace boards, the switch will be pushed up instead of right. And in the upflow furnaces. When you first power up the RDS boards during initialization, which is about 5 minutes, they will go through a kind of purge sequence and self-detection sequence, looking to verify that you've connected your 1 or 2 sensors and that the system is basically connected correctly. It'll identify any potential errors and during setup, and basically flash any code during code on the if there are any errors during the actual initialization portion. We'll go over those codes shortly. A quick note on the outdoor unit here. So let's go through this variable thing real quick because I want to make sure that we kind of cover it off. Not terribly often, I think you're going to see this, but if you do happen to see some of these variable units during startup, when you're using a fully communicating control like the S40 or a traditional 24-volt thermostat, the RAS connectors that are shipped with the equipment need to be connected to the terminal here on the bottom left that you can see highlighted in green. There's actually 2 connections, 2 connectors that sit in that single block. Please make sure that they're left there. So, I mean, maybe they're connected to a 24-volt system and then later they get upgraded to a fully communicating system and want to only use the 4 wires. Certain portions of that connector still need to be there, or vice versa. If it goes from a communicating system, that thermostat fails on a Friday night, maybe our service technicians need to go out and make it functional for a 24-volt thermostat. Well, then they're going to have that connector. Please make sure that they're left there. Where am I here? On the bottom right of the control is a series of jumpers. So you can see highlighted in red there. One is for, you can see now in the blown up version, one is highlighted in blue, one is for defrost termination temperature. We've talked about this previously in other let's say Lennox-based trainings. Lennox has suggested that a minimum of 70 degrees defrost termination temperature. I'm going to suggest to you up to 90 as well. We want to make sure in the event there is ever when there is a defrost sequence, that the defrost is run long enough and hot enough to completely clear the outside of the coil. 50 is too low. I mean, maybe in Florida it would work 50, but I would like to suggest that if we're gonna operate heat pumps in this climate, in our Canadian climate, 70 as a minimum, 90 preferred. Please make sure those are set up. There's also for the service people out there in the world, and if for some reason during install you want to actually test the defrost functionality, there is a jumper there to do so. And there are instructions on how to do that. You just jumper across the pin. Otherwise, just leave it in place. And then for the variable speed equipment, variable speed equipment, compressor equipment, there are a series of selectable, we'll call them suction pressures, basically. The good news is for you guys, I would just leave them where they are. You don't need to change anything. There's an efficient mode, which is the most efficient mode. It will variably follow the outdoor temperature and adjust the suction pressure accordingly. There is a normal function, which holds or locks the suction pressure in at 135 psig, and basically makes sure that at whatever temperature it is outside, you're consistently getting 135 psi. And then there's efficient, actually going to back up before we move to the efficient heat. If you were to take one of these jumpers off, there's also a low mode or a cool mode. Basically what it'll do is it'll lock it at 125 psig and allow it to function consistently at 125 psig. Doesn't matter what the temperature is. So it kind of locks it in at a specific suction pressure regardless of temperature. So you're always going to get a consistent output, basically output temperature. I'd be more inclined to follow the most efficient operation. Just leave it the way it is. You don't have to adjust anything. And then, of course, the only other one that was just highlighted, which is efficient heat, is the heat pump side of things. Just leave it in place. Same thing. It will variably follow the outdoor temperature and the suction pressure that's coming back to make it at the most effective operation possible. And then this is what's more important maybe to you guys. This will help you guys as installers and help get things charged a little more quickly if you're using a variable piece of equipment. To initiate charge mode function, install the jumper across the two charge mode pins. You can see where it's highlighted in green there on the right side. What this is going to do is in a communicating system, it's going to force the entire system to 100%. In a communicating system, the communication will recognize that you've forced it into charge mode into 100%, and it will kick the blower up to 100%. Here's the caveat in a 24-volt system, however. Before you jump this charge mode pin, you need to get the fan indoors to the Y2 cooling speed, which is high speed, whatever it's been set up for the appropriate total external static pressure and CFM value you're looking for. So there needs to be a call at Y and there needs to be a call at O specifically for Lennox. So they may need to be jumpered in order to get them to function. And then you can push this charge mode pin on and it will take your outdoor variable compressor to 100% and allow you to charge more quickly. Make sense?
So if you don't do that on a variable furnace, what are you doing? Just waiting for a time period?
For the
like
furnace fan.
If you don't.
You mean for the furnace fan? Yeah, I would think you'd have to wait.
Okay. If I could clarify something.
Or unless you jump it in inside, run to your cooling speed.
This is a must then if you've got a variable furnace.
Mm-hmm.
Got to get it into 100%.
Mm-hmm.
Okay. All right.
Mm-hmm.
Okay.
Yeah, and not only that, for your own sake, when you're doing your commissioning anyway, you're moving to 100% anyway. So this charge mode could be, even if you're not charging, just if you're commissioning, is another good way to get it to run to 100% so you can verify its operation.
Well, that's what I was talking about for the installer on here. That's all. Yeah.
Yeah, for sure.
Cool.
For sure. Sorry, Terry, go ahead.
Yeah, if I may clarify something. So Lennox with their variable speed furnaces that are non-communicating in that, or that have the communication board on it, they will actually run for 7.5 minutes on the lower speed, around 80%. So they set up their ramping profile. Unlike others, they'll ramp it up for about 7.5 minutes, and then it'll go to the high speed. So you can change the ramping profile on the indoor board if you like, so that it goes immediately to 100%, but you want to switch it back for the efficiency's sake.
Yeah, I see what you mean. Yeah, you want to, like you're suggesting, go to ramping profile D to 100%.
That's right.
Yeah. Yep, that's another way to do it. You could skip the fan profile. But what Richard was suggesting is that if you're going into heat mode, or sorry, even a cooling mode, you're gonna have that delay on blower. And that in order to prevent that, you got to jump to high speed somehow, or force high speed. And this is one way to do
So
that.
there's
Is
either
to make
way,
sure
either
that
way you can.
Mhm.
Well, either way you could accomplish that. Like what Terry said, you could accomplish it that way in cooling, right?
Yeah, we got a couple options there. And we just for commissioning's sake, it makes hopefully what it does is makes the installer's job quicker and easier.
That's what I'm looking for. Yeah. Okay.
Yeah. Either you can wait the 7.5 minutes. It takes 30 seconds for the first part, then another 7.5 minutes until it reaches 100% inside. If you don't want to mess around with the dip switches for the ramping profile. So if you give yourself 8 minutes, then what you're going to do is you're going to take a look at the board inside. It's at the 7-segment display. It'll actually show you the airflow when it gets to the high percentage. So typically you'll get the C2 and then you'll get the C2 right off the bat, but there'll be a time delay. You might see on a 2-ton, it'll be around 650 or somewhere around there. But at the end of the 7.5 minutes, you'll be at your 830 if you've adjusted the dip switches on the furnace inside.
Yep. Okay. Thanks, Terry. Thanks, Richard.
Jim, may I also ask about this? It's Anthony.
Sure.
So for this outdoor variable unit, wouldn't it be required to have an S40? And so no,
you can run with both. Yeah.
Oh, would it need the EIM, or you can just run 24V?
You can run 24 volts, man. Totally. The only scenario where you would need an EIM is if you've got a non-communicating piece of equipment inside. Actually, no, I don't even know if you need that.
Okay. Well,
the only reason you would ever need an equipment interface manual is if you're putting in a communicating piece of equipment or a heat pump outside, or a non-communicating heat pump with a communicating system.
Okay, I see. Now, I guess my question then is, if there is an S40 installed with this variable outdoor unit,
then we can ignore it.
You don't need this charge jumper. You don't need to do anything with this charge jumper. Then the S40 can handle run it at max, and then it'll run the indoor.
Yeah. So with the S40 version, you can go inside of the S40 and force it to maximum through your installer settings or your advanced settings. Or if you're working outside and you want to jump this jumper, the entire communicating system will recognize that you've done that and will force everything to 100% immediately.
All right, great. Thank you very much.
Yeah, much faster for the installer, especially if it's communicating. You just jump this jumper outside and go to work. Start taking measurements. All right, this is where it gets exciting. This is the new stuff. To confirm, this is again specific to the Lennox. I don't know how Carriers is going to deal with it. It's probably very similar. And Goodman, we're going to get into the test button. We push it once here. Lennox, or for Lennox, for the Goodman, Man, and Dakin stuff, you're going to push it twice within 5 seconds, and it'll go into its test procedure. But the process is basically the same. To confirm the low GWP sensors and safety controls are functioning, you will perform 2 very simple tests, which are very, very quick. So let's assume we've got a standard system with one sensor, and it's connected, as you can see pictured, to sensor port number 1. In our example, let's assume we'll use this either A2L equipped control board that is, it would be from an SLP 99, or on the left is the legacy furnace with the external control. Your first step before testing is to go to the dip switch settings number 2 and move it to the on position. So again, on the left-hand side where the external RDS board is, you're going to push that to the right. And on the board in front of you, you can see on the SLP board, there's 2 dip switches. Number 2 would go up. So now the control board is really only looking for 1 leak sensor instead of 2. Now, on to testing. So on each of these control boards, you can see highlighted in yellow that there is a test button or leak event button. So in order to test, first we have to force the equipment into we'll start with cooling, into a cooling call. Let it get to a point where it's stabilized, the fan's running, the refrigerant pressures are operating normally, and simply push that test button one time and then release it. What should happen if this is set up correctly is the air conditioner outside, after a short period of time, if not immediately, should shut off. So the compressor should stop running, the outdoor fan should stop running. And the indoor fan blower should move to this cooling speed that you've set up for fan only. So basically what will happen is the indoor blower will run to its dissipation CFM rate, whatever one you've set up for it. For the communicating Lennox equipment, oftentimes what that will be is a fan only speed, which typically is a low or a continuous fan speed. It's kind of low. So you got to make sure that you've got the appropriate CFM that was labeled earlier on in that chart based on your refrigerant charge. For the non-communicating systems, you may find that it moves to the cooling speed, but please confirm you've got the right fan speed when you're set up. Once you've validated that the outdoor unit did in fact shut off and the blower continued to run to dissipate, on the board you'll see a leak. It'll be in leak test procedure. On the 7-segment display on the board on the right, it will show you that it's in a leak mitigation error code, and we'll see a list of error codes shortly for that board specifically. Once you've confirmed that it's shut off, simply push that test button one more time, and what it'll do is it'll take it out of that test mode and go right back to its normal operation. And you validated the cooling function during a cooling function, that if there was ever a leak, that leak mitigation process will happen. In heating, you're going to follow the exact same sequence. So we're going to provide a heating demand from the thermostat and allow the furnace or heat pump or electric heat strips in an air handler to run and basically stabilize. The fan gets started, it's starting to deliver heat. You've established a solid call for heat. And the process is still exactly the same. Go ahead and push that test button one more time, give it a little push, and then release it. What'll happen is the burner should shut off after a short period of time. The electric heat strip should shut off, or the heat pump should shut off, depending on what heat function is running. Confirm that they stop, and simply push that test button again to come out of that test function. Those are the two tests to commission to make sure that that system is working appropriately. And then again, God forbid there's ever a refrigerant leak with the A2Ls. In this case, it would be R454B, that the leak mitigation procedures will function. It'll dissipate any potential leak around the house to keep it way, way, way below its lower flammability limits. Again, just a reminder, for Lennox specifically, theirs is going to turn on at about 1% concentration of the lower flammability limit. Lennox's sensor picks up, I think, around 12% of the lower flammability limit. I think Carrier's is either 15 or 17, but they're all kind of in that same neighborhood. They're all going to mitigate refrigerant down at that kind of 1 to 2% concentration level. Well below the lower flammability limit for sure. And then, of course, please make sure that those tests were done and that they've been documented in some way within either paperwork or electronic reporting procedures where you're doing. If it isn't written down, it wasn't done. And with this new A2L stuff, we want to make sure that when it's completed, it's been documented, that the tests are going to ensure that the refrigerant detection dissipation stuff happens.
Would you call it a dissipation test?
Basically, yeah.
Is that what it's called? Okay.
Yeah.
All right.
Yep.
Okay.
Yeah, hopefully it'll just update the installer form they're already filling out with the extra line item.
Yeah. Simple.
That would be great. Yes, we need that. Yeah.
For those of us who are coming in and putting this stuff in and going through this process, again, Lennox specific, I'm going to go through their stuff. I have no doubt that the Goodman, the carriers have their own functionality. It's going to look very similar to this. When this board is first powered on, as discussed earlier, it goes through a kind of this discovery phase. It goes through its initialization, and you're going to see this green light on the kind of the top left of this external board flashing green. Once it's finished going through its initialization and everything is okay and set up correctly, what's going to happen is that light's going to go completely solid. And as long as it's solid, you know your mitigation stuff has been set up correctly, or it recognized the sensor or sensors that you've put on it, and it's in fully, it's able to communicate with the thermostat and the indoor unit. I mean, a reminder, these are simply just pass-through boards. It's just a break in your thermostat wire, essentially. There's not really much going on here until there's actually an error. And when there is an error, you'll see that green light start to flash blue if it's in mitigation mode. So if you're doing your testing, this is what you should see, a flashing blue light. God forbid there was an issue. If it's solid blue, what will happen is now you'll be interrupted by some sort of diagnostic code on the table below. So you'll have this solid blue light, then interrupted by a red diagnostic code, red light LED. So this single LED is multiple colors and will kind of identify if there's a problem. If you had a sensor problem or some sort of setup error, you're going to get some sort of flash code somewhere within this board to tell you whether it's the wrong sensor, or you don't have the sensor in the right port, or it's the, you don't have your dip switches aren't set correctly, etc. And we'll go through this kind of 1, 2, 3, or 4 individual faults. Once it's corrected, all you got to do is push that leak test button one time, and everything should go back to being green. Assuming that the fault has been corrected. Let's assume it's maybe the sensor's in the wrong port or something. Now, one thing we learned while we were in Ottawa, Bill and I were in Ottawa, we were talking to Ian from Lennox, is in the event, and again, this is very Lennox specific, so I want to make sure I'm saying this correctly. In the event the Lennox RDS sensor fails, it doesn't have a refrigerant leak, the sensor itself has failed. This may be more for the service folks. If the sensor has failed, or is something wrong with the sensor specifically, it will not, this board will not lock out the customer's heating or cooling. It will just notify that the sensor has failed, that the sensor has to be replaced. Otherwise, they'll still have some of their heat or some of their cooling. It will still function, only if the sensor itself is faulty. Otherwise, if there is a leak, then no, they'll lose their heating, they'll lose their cooling. And then once this sensor has determined that it's below the lower flammability limits, somewhere between 5 and 7 minutes, it will run the fan at the end of that dissipation, and then go back to normal operation. Terry?
I know this is also on the service side, but is there a life expectancy of these sensors, considering they're supposed to be sensing
your guess
vapor?
is as good as mine, man. Yeah, your guess is as good as mine.
It's like they say with all the gas detectors that they have out there, you want to replace them every 10 years or something. So my thinking is, if a guy goes back in later on to replace one of these units, do we have to replace the sensor?
In my opinion, from a service guy's perspective, I would probably change the sensor, but yeah.
Oh, I mean, like, if we're replacing a unit like 5 or 6 years down the road, like, will the
hard to know,
installer
man.
replace it? Yeah,
hard to know
when they replace the AC.
Yeah, and they're not meant to be like serviced anyway. I mean, you can you can brush them if they get dusty, but other than that, they're not meant to be serviced. They're a fixed sensor. They're not meant to be touched or played with.
Mm-hmm. Okay.
But from a life expectancy, hard to say.
Jim,
this is yeah. Sorry, what's up, Anthony? What's going on?
Is there a way with the multimeter to test out the sensor, or is it just the board will say it's good, it's no good? Nothing
that we've ever heard or seen. I've been told that they have 5 volts to them It's a small little heater on it. But as for the sensor itself, no, we don't have any data that states that there's some sort of specific resistance value to them or something. Nothing
Okay,
yet,
and you were
anyway.
saying that it would not shut off the cooling if it was a sensor fault. It would just show a fault.
If the sensor was faulty, correct? Yeah. Yeah.
Okay,
So if you
thank
look
you.
over here, where is it here? Sensor fault, refrigerant leak detection sensor fault. Where is it? Or sensor type is incorrect. You'll have, if there was a sensor fault, and it may not, it'll give you a different error code, but it won't give you it won't lock out your heat. Right? They're two different faults. That's a refrigerant leak detected fault, and that's a sensor fault. And the process is the same with this. Exact same thing. Use the test button. Sorry, I'm going to back up one right here. Use the test button on this board right next to the diff switches, which is over, see here, low GWP test button. Same process, and it'll go through. You'll see on the 7-segment display, the fault will display. Same process, though. Oftentimes when we switch refrigerants, there is some concern that the pressures are going to be different. I've kind of already hinted that the pressures are going to be very similar. But there is a key difference with R454B that wasn't as prominent in 410A, and they never had to identify it on their pressure temperature charts. 454B has 2.5-ish degrees of glide between its vapor state and its liquid state for saturation temperatures. 410A actually has a degree and a half of glide, but they never actually charted it. So it wasn't as prominent or wasn't as drastic, so it didn't really have to be charted to the point where it could affect what you're really seeing for subcooling and superheat when you're taking your measurements, when you're doing your commissioning specifically, or when guys are doing service work. But R454B is different. So if you're taking a superheat measurement and you're actually going to compare it to a gauge temperature or pressure, saturated condensing temperature or saturated suction temperature, you've got to make sure you're using the appropriate column on the chart. So when you're on the suction line, you're going to use vapor, and when you're on the liquid line, measuring the liquid line, you're going to use the liquid temperature column. So just something that is one of the minor differences to be aware of. Not a huge deal, but a minor difference. And then when it comes to pressures specifically, 43-degree refrigerant temperature, not unusual for R410A, 125 psig, completely normal. 43 degrees, give or take, for R454B on the vapor side. It's a little less, actually, about 10, 12 psig less. It's actually, pressure is actually slightly lower. And then same thing on the refrigerant side. So for 110-degree liquid temperature at 365 psi, which is actually kind of high for 410, you can see here that it's even a little lower. So instead of being, say, 365, you got like 346, give or take. So it's a little bit lower for R454B. If you happen to see R32 out in the field, you happen to be installing some of the Goodman or Amana product line, the operating pressures are almost identical, just slightly higher. You might see an elevation of 10 psi based on beyond what 410A is already providing, or what we're seeing with 410A. And because R32 is a single. Oh, sorry. Go ahead, Richard.
No, sorry to interrupt you. I didn't mean to do that, but I do have a question.
Yeah, sure. Shoot.
As far as we're concerned, though, like we're using new gauges with, it has the temperature, the pressure.
Mm-hmm.
Like we don't use TNP charts, so like we're good, right? Like
it should be, yeah, should be listed
or whatever, or
listed on the
as per normal.
Yeah,
like we're not using a different gauge for this gas, is what I'm saying. We're using the proper one.
That's correct. As long as it's listed on your, should be fine. Yep.
Okay, cool. All right.
Yeah,
I'm just
absolutely.
getting confused with all this, man. This is a good time for an old guy like me to get the hell out of this trade. Anyway,
and a lot of the guys said the same thing with 410A when the pressure's doubled.
Anyway, we're good. I just wanted to clear that. Okay. All right, man.
Yeah.
Thanks.
Yep. No problem. And I said just R32 is almost the same, but you can charge it with liquid because it's or liquid and vapor because it's a single component. Just a reminder. Setup. This is Lennox's setup in their manual. Wet bulb, dry bulb to get an expected delta T across the coil. So if you were to use this example on their chart, if you had a 64-degree wet bulb temperature and a 72-degree dry bulb temperature, Lennox expects across your coil you'd have 15 degrees, not plus or minus 1 degree. If you have more than that, like they show right here in their first example at 53 degrees, which is 19 degrees, there's a really good chance that you've got inadequate airflow and the airflow needs to be increased. Basically what's happening is the air, as it passes over the coil, has too much time in contact with the refrigerant and you're getting too much temperature difference. Probably don't have enough airflow. You can speed it up. Say if you had again, taking the same readings, you end up with 58 degrees, which gives you basically a 14-degree TD. That's much closer to the expected 15. Perfect. Airflow is set up correctly, and you know you're getting the appropriate temperature difference across, and there's a good chance your refrigerant is charged correctly. Confirm with superheat or subcooling, depending on what orifice or TX valve you're using. One last kind of one last kind of chart that's in the for setup and commissioning is Lennox offers this on their on the inside panel of the outdoor units or within the manual for the air conditioning or the air conditioner or heat pump. So in our scenario, let's assume we've got a 3-ton unit on an 85-degree day. You have some typical operating pressures. 301 for your high side pressure, 132 plus or minus 5 psi or 10 psig, depending on what you're reading. If you're getting these pressures or somewhere within these pressures, really close, there's a good chance your charge is going to be correct. But Lennox likes to validate further and give you the opportunity to check through approach, which is your outdoor temperature entering the outdoor unit versus your pipe temperature. If you have a difference of 3 to 5 degrees, or basically they're giving you 4 degrees, again, your charge is probably correct. If you have some differential, you might have to remove or add refrigerant depending on what you find. And then, of course, our more likely measurement is subcooling. We're typically going to commission and validate our charges correct with subcooling. In this scenario, on an 85-degree day, a 3-ton unit, Lennox is going to have approximately 11 degrees of subcooling. Does anybody not know how to measure these before I move on to the next slide?
Actually, I was just wondering.
Go
ahead, Terry.
When it comes to checking the temperatures and wet bulb, I've spoken with many techs, and it doesn't seem like too many people have a sling cyclometer or a enthalpy sensor, like electronic. And I'm wondering if that's going to be, are they going to be issued with those so that we can verify this? Because dry bulb alone is not going to help us out really with diagnosing issues.
I'm not going to lie to you here, Terry. I have no clue how that stuff gets dealt with, tools and stuff. So
no, we're shoving a wet, damp shoelace on a freaking. No, we don't. Some of us have them, but yeah. So we probably should have them for sure. We should all have them. I agree, Terry. Yeah. Okay. I had a question.
There's a poor man psychrometer. You can build yourself a poor man psychrometer. You can put a small piece of tissue or paper towel on the end of a dry bulb thermometer and leave it in the return for 5-6 minutes. It'll start to produce a wet bulb temperature for you. No, I mean, kind of not the most professional looking, but it will do the job. It will do the job. But as for tools, I'm definitely the wrong guy.
You asked the question if everybody knows how to do it, and I presume all of our installers do. But is there? You said that example you gave was roughly 11 degrees on that 3-ton at 85. Now, is there a plus or minus on that, or is it?
Yep.
Yeah, for
plus or minus half 1 degree.
1 degree. Okay.
Yeah.
Okay. Thanks.
1 degree. Yeah, there's going to be some variability, right? I mean, we're dealing with refrigerant pressures and really, let's face it. I mean, indoor conditions will also kind of change how things operate. Outdoor conditions can change how things operate for sure. So there is going to be some minor degree of variability.
Yeah.
In these readings.
Thanks.
Sure. Yep.
Just throwing it out there. If you need
True.
the tool, go get it. If you're working for Enercare, they're going to want you to have the right tools.
Absolutely.
Yeah.
I
Talk
would
to your
think so.
manager. They may help you out already.
Well, there is a tool allowance too, Terry. I always forget sometimes. I guess there's a tool allowance too. So that's a way
Digital tools are covered though. So if you've got a digital
Oh, there you go.
Yeah, like I normally recommend the digital hygrometers, and I've always used two, one before and after the evaporator coils to measure the performance.
Yeah, I had one too.
Just
I
don't
had
go
one
out
too.
and buy it. Talk to your manager and let them source it.
Yeah,
There you
guys,
go.
again, this is nothing new with the digital psychrometer. We brought it up years ago. I stressed the fact that, everybody should have one, go get one. Without one, we're just, we're guessing, right? So it's so important. It's nothing new. And we brought the digital psychrometer up years ago, and we continue to do that every single year. Like we put these AC refreshers on every year, and it's one of our first things that we talk about is that digital psychrometer and how important it is with relative humidity and wet bulb. And so I'm surprised to hear that. It doesn't make me feel all warm and fuzzy that our technicians aren't equipped with it, but it has definitely been brought up in the past, and I don't feel all warm and fuzzy about that.
From a manager's point of view here, guys, I don't think anybody's going to deny anybody a digital psychrometer, and we should all have them. So I can tell you that some of the techs have them in our patch, the service technicians, and some don't. And but definitely, I don't think there's any manager that's going to deny you the proper tools to do the job.
Yeah, makes sense. And then, of course, finally, make sure your stuff is documented. Anything you're doing, checking models, serial numbers, any commissioning, any other thing beyond the normal operating pressures, subcooling and refrigerant charging, ODP stuff. Make sure we've got all of our commissioning documentation taken care of, manufacturer and Enercare related. And now we are at questions. Did anything show up in the chat, Bill, that I maybe overlooked or we didn't get to or didn't cover?
No, sir. Everything was brought up during.
Brought up during. Awesome. Okay. Anything that is lingering that people are kind of humming and hawing about?
There's actually one question I had in mind is with regards to the evaporator coils and expansion valves. Most of the Lennox coils, they typically would like to see the sensing bulb relocated to outside of the cabinet so that you get true suction sensing. And with those boots on, I didn't see anything in place. So if they got a boot on there, you're going to have to wrap it, or are you expected to move it down further, like 12 inches?
I don't think you're going to be able to move it, Terry.
Okay.
Looking at where those things are, especially if you're talking about a cased coil, a non-cased coil, different story. You might have to move it under the boot.
Yeah, if it's underneath the boot, it still has to be wrapped, right?
Yeah, I would think so.
Yeah.
But I think with those sleeves, there's actually a wrapping process before the sleeve slides on it anyway.
Is it? Okay.
Yeah, it comes. I think the kit, if I'm not mistaken, the kit actually comes with like an insulation tape that you put over the pipe first, and then slide the sleeve over.
Yeah.
Mm-hmm. Yeah, because you're still going to get sweating there, right?
Exactly.
Yeah. Unless it's
on
properly
the
insulated.
case coil. Yeah, guys, on the case coil, it is a fixed position on the case coil, so I don't recommend moving it.
Mm-hmm.
But surely enough, again, if you're going in with an uncased coil, it's always a good idea to locate that bulb outside of the plenum, securely strapped, as Jim, I think you probably highlighted, right? So yeah, on the case coils, guys, it's fixed, it's strapped, and there's no reason to move it. So
yeah, the only thing you'll probably have to be careful with is where the sleeves connect to the ductwork is where you'll probably have to bring that bulb line out. The same hole as the suction line, so that the sleeves will properly cover the penetration.
Sounds good.
Yeah. Good question, Terry.
You're quite welcome.
Yeah. Does anybody have any questions for Anthony
I have a
about
question.
his label maker?
I have a question.
Yeah, shoot. What's up?
This is coming from like an installer's perspective.
Yeah, sure.
It'd really be nice to see this stuff like in a lab setting and you know, tweak the dip switches and get a feel for kind of what we're going to be seeing out in the field. I know there's a lot of information here, a lot of good information, but I just was wondering if we could get some more like hands-on stuff.
Well, you're speaking to the right folks. We'll I'm sure they'll who am I talking to? I can't even see who you guys are.
It's Curtis Roy. I'm under Caitlin's iPad here because I can't sign into Microsoft Teams.
Okay. Which center are you in, Curtis?
We're out of the Peterborough.
Awesome.
Yeah.
Okay.
Well, yeah, no, like any like it's good to watch this, but it's also good to see it and actually physically be able to tweak some things here and there. So
sure, I agree.
Maybe
I know that we've definitely got it on you've definitely got the right people's attention. The only thing I would suggest is maybe talking to your manager too. Who's your manager?
Richard. He's on here.
Oh, Richard, he's on the call. Okay, so maybe Richard and Tommy can get together and find a way to put something together if there is even something available yet. I haven't even seen. I think there's product in our lab yet. Tommy, can you validate that or verify that it's showed up?
Yeah, we just got the product in not too long ago. So hands-on, guys. Yeah, I mean, it's always great to get your hands on it, right? But at the end of the day, I mean, it's really a circuit board and a sensor and a dip switch and a test button. But yeah, sure, we can set something up and be a real quick, just hands-on. So this is the board. Here's the dip switch you got to push, and the test button you got to hit at the end of the day. So. Yeah, I mean, we can set something up, Richard.
I've got an idea, actually, Tommy. I do have an idea. We'll chat later.
It's new, and I think Curtis has a good point. I mean, I really appreciate this training, and you did a fantastic job. All you guys, thank you. And the questions were good, but there's nothing like just being there, touching it, seeing it, doing it, having explained again in real life.
Yeah,
I think that will go a long way for us to be able to proficiently install these systems.
It might make our first installs go a lot more smoother, right? Like, we're not like second guessing ourselves.
Anyway, we'll take that away, Curtis.
Okay. I got a good idea, actually, Tommy. I wouldn't mind passing it over. I'll pass it to you or throw it over the wall at you and we see how it lands, and we'll talk about it after.
Sounds good.
Thank you.
Just come to mind, but I don't know. Might not be the best idea, but maybe it spurs on something else. So,
I actually just found the sensing bulb on for the TX valve. I posted it in the Teams chat.
Cool. Let me see. How do I get out of here? See, this is why I can't. Sometimes just.
Question.
Yeah. What's up? Yeah, there it is, mounted to the unit.
Yeah. Right after you satisfy everything, subcooling and fan speed, then you find out that there's a temperature dip, the delta T across the coil is out of whack. Now, if you adjust the fan speed to satisfy the temperature difference, it will change your subcooling. Which one do you adjust first?
I would always adjust my airflow first and then charge to the manufacturer's spec based on line set and coil size, and then adjust your charge after the fact.
The airflow is always 400 CFM, right?
Ideally 400 CFM per ton, but I would check with the manual to confirm.
Yes. Now you want to check the temperature difference, but your subcooling is different too. So which one do you adjust?
Sorry, say again. I missed what you said.
Let's say we satisfy 400 CFM, and we satisfy the subcooling outside, temperature all okay. Now we go into the unit, we check the temperature difference on the coil, and it's not correct. Now if we adjust the fan speed again, it will change the subcooling. What's the
Yeah.
will there be a
I don't. Well, if your charge is correct and your fan speed is correct, and you've got
Yeah.
and your temperatures are being measured correctly, it sounds like you got it dialed in. I don't think you're going to have any that kind of variability.
And you
You
should.
should.
Again, these are all, it's again, those charts that you saw Jim put up on the screen just a few weeks, those are all engineered specs, right? So if you're dialed in on your CFM, the static pressure test, dial in your CFM, dial that subcooling, you're good to go, bud.
Yeah, I think you're good to go. Now the thing is if you're having unusual
Jim,
temperature
uncover your
readings,
ears when you talk.
Oh, sorry. Yeah. If you're having unusual temperature readings, sorry. Yeah. I was trying to hear before the, I would go back to your temperature probes and confirm that they're still good.
Mm-hmm.
Put them in a glass of water and ice and make sure they read 0. Make sure they're dialed in. Because if you're getting some weird temperature readings and weird anomalies like that, I would start with my instruments. If I know my other stuff is correct, my pressures look right, my subcooling looks right, my temperature difference looks right, or my fan speed is right, but my temperature's out, I'd be more inclined to check my thermometers, make sure they're working correctly.
James, there's actually one other thing when it comes to the Lennox units, and that a lot of times they tend to oversize the evaporator coils. So if you're installing an evaporator coil like a 2.5 ton on a 1.5 ton unit, which is commonplace for Lennox units, you'll probably end up having to add a fair amount of refrigerant. Sometimes on the inside panel of the cover for the service panel on the condensers, they will actually show your required additional refrigerant based on the size of the coil. And if you follow that chart, especially on the heat pumps, if you follow the chart and make sure you got a matching coil that's on the inside of those covers, and then use the 3 ounces per 5 feet rule for your additional line set length, you're going to
most of the time,
you're going to be pretty damn close to your readings where you should be. You want to give it, of course, allow it to 10 to 15 minutes to run. If it's a heat pump,